Welcome to G Fun Facts Online. Today, we're going behind the curtain of a massive $400 million transformation that has redefined air travel in India. Air India, under the stewardship of the Tata Group, has embarked on a monumental journey to reclaim its status as a global aviation leader. At the heart of this revival is a spectacular overhaul of the workhorse of its fleet, the Airbus A320 family. This isn't just a fresh coat of paint or new seat covers. It is a deep-rooted, multi-million-dollar engineering endeavor aimed at enhancing passenger experience, optimizing efficiency, and setting a new standard. The story of how they successfully retrofitted over 100 aircraft is a masterclass in modern aviation engineering, logistics, and strategy. The project was a cornerstone of Air India's Vihan.ai transformation plan, and the initial phase, refurbishing 27 Legacy, a A320neo aircraft, was remarkably completed within just 1 year, starting in September 2024, despite significant global supply chain challenges. So let's delve into the intricate engineering details that breathe new life into this iconic fleet. The most visible part of this revitalization is the brand new 3-class cabin. This marks a significant departure from the old layout, because for the first time on its narrow-body planes, Air India has introduced a premium economy cabin, offering a new choice for travelers. Let's break down what's new, starting at the front. In business class, there are 8 ergonomic seats, a variant of the highly regarded Collins Aerospace MiQ platform. These aren't just seats, they're personal productivity and comfort zones. They boast a generous 40-inch pitch, which is the distance from one point on a seat to the same point on the seat in front of it, and a deep 7-inch recline. They feature adjustable armrests, footrests, backrests, and a tray table that deploys at the push of a button, complete with a personal electronic device holder and multiple charging ports. To give it a touch of sophistication and durability, over 450 meters of premium leather were used for these seats across the fleet. Next is the brand new premium economy cabin. With 24 seats, this is a strategic move to cater to the growing segment of travelers who want more comfort than standard economy without the full price of business. These seats, based on the Collins Aerospace Meridian platform, offer a wider 32-inch seat pitch and a 4-inch recline, a noticeable upgrade. Passengers here enjoy superior upholstery, a 4-way adjustable headrest, and dedicated amenities like a device holder and USB charging, complemented by an enhanced meal service. But the transformation didn't stop there. Even the main economy class cabin, with 132 seats, underwent a significant upgrade. These seats, also from the ergonomic Collins Meridian family, prioritize passenger comfort even on shorter flights. They feature a 28 to 29-inch seat pitch, a 4-inch recline, and thoughtful details like a personal device holder, a tray table, a coat hook, and critically, a USB charging port at every single seat. Across all classes, the entire cabin ambiance was refreshed. Over 5,000 square meters of new carpeting were laid down, along with new curtains and cabin panels featuring fresh design motifs. A key element of this new ambiance is the subtle cabin mood lighting, provided by a company called Astronics. This advanced LED system changes the color and intensity of the light to create a soothing and relaxing atmosphere during different phases of flight, such as the gentle blues and oranges of a sunrise during boarding, a calm ambiance for meal service, and a gentle transition to darkness for overnight flights. But how do you actually do all this? Swapping out nearly 25,000 seats and adding new features to an airplane is a monumental engineering feat that goes far beyond a simple replacement. Let's start with the structure of the aircraft itself. Changing the entire cabin layout, or what engineers call the layout of passenger accommodations, or LOPA, is like solving a complex, 3-dimensional jigsaw puzzle at 30,000 feet, where every piece must fit perfectly and meet stringent safety standards. The seats you sit on are bolted onto tracks on the aircraft floor, and these tracks are a critical part of the airframe structure. When you change the seat pitch and the entire configuration from 2 classes to 3, Engineers need to conduct detailed structural analysis to ensure that all the loads transferred to the floor structure during flight, turbulence, or even a hard landing remain within the aircraft's certified limits. Furthermore, you have to install new cabin monuments, like the partitions that separate the new classes. These aren't just flimsy walls for privacy. They are certified safety components that must be able to withstand intense dynamic loads without breaking loose and becoming a hazard to passengers. This involves a meticulous process of designing, testing, and certifying every single new attachment point to the aircraft structure. Then there's the power problem. One of the single biggest engineering challenges in any modern cabin retrofit is providing in-seat power. Passengers today expect to charge their personal electronic devices. Air India's retrofitted A320s deliver on this with both USB-A and USB-C ports available at every seat. However, providing simultaneous power to over 160 seats places a significant new demand on the plane's electrical system. Before installing these, engineers must perform a critical safety assessment called an electrical load analysis, or ELA. An aircraft's power budget is finite, carefully shared between critical systems like cockpit avionics and flight controls, galley ovens, and cabin lighting. The ELA ensures the aircraft's generators can handle the increased load from hundreds of new USB ports without overloading the system. A power overload is a serious event that could lead to a loss of power to critical systems, so this analysis is absolutely non-negotiable and often requires an airworthiness directive for compliance. Air India worked with Astronics, a specialist in aircraft electrical power systems, to install their lightweight and efficient M-Power in-seat power solutions. These systems often use a distributed zonal architecture with high-efficiency power supply units, carefully engineered to provide the required power while minimizing weight and impact on the aircraft's electrical grid. Next is the delicate balancing act: weight and balance. Every single component added to or removed from an aircraft affects its overall weight and, more importantly, its center of gravity. These parameters are absolutely critical for safe and efficient flight. While modern seats from manufacturers like Collins Aerospace are often designed to be lighter than older models, the introduction of a new cabin class with more luxurious, feature-rich seats in business and premium economy can still lead to significant changes in the aircraft's weight distribution. The engineering team must meticulously calculate the new weight and center of gravity of the retrofitted aircraft to ensure it remains within the certified limits for all phases of flight. An incorrect center of gravity can have serious implications for the aircraft's stability and control, making it harder for the pilots to fly safely. After the retrofit, a whole new weight and balance manual must be created for the aircraft, a legally required document that the flight crew uses for every single flight to ensure the plane is loaded correctly. Finally, there's the digital experience. The new cabin features an in-flight entertainment streaming service called Vista Stream, offering close to 900 hours of content that passengers can watch on their personal devices. But providing a reliable, high-quality streaming service to hundreds of devices on an aircraft moving at over 800 kilometers per hour presents its own set of engineering challenges. For this, Air India partnered with Thales, a global leader in in-flight technology. They implemented solutions like the Thales Avant IFE system, which is built on an open architecture platform, allowing for easy updates and the integration of new apps in the future. The engineering work involved installing onboard servers, wireless access points, and a sophisticated content delivery network within the aircraft. Antennas had to be carefully placed to ensure optimal Wi-Fi coverage throughout the cabin, and the system needed to be robust enough to handle simultaneous streaming by a large number of passengers without any buffering or degradation in performance. A project of this scale and complexity is never the work of one company. It's an orchestra of collaboration. Air India's in-house engineering team acted as the conductor, masterfully coordinating the efforts of a host of global and domestic partners. Collins Aerospace played a pivotal role, providing the 25,000 new seats. Astronics Corporation was responsible for the advanced cabin lighting and the crucial in-seat power systems, and the Thales Group provided the expertise for the in-flight entertainment and connectivity solutions. Significantly, a large portion of the actual retrofit and repainting work was carried out in India, showcasing the country's growing maintenance, repair, and overhaul, or MRO capabilities. For example, Indamar AAR Technics facility in Nagpur was tasked with repainting and retrofitting 12 of the aircraft. This not only highlights the Make in India initiative, but also demonstrates the cost and time efficiencies of performing such complex tasks domestically. Air India is even looking to the future, establishing a new MRO facility in Bengaluru with a partner, which will further bolster its in-house capabilities. Now, you can't just modify an aircraft and start flying passengers. Every major change requires the stringent approval of aviation regulatory authorities, which in India is the Directorate General of Civil Aviation, or DGCA. For a major modification like a complete cabin reconfiguration, an airline must obtain a Supplemental Type Certificate, or STC. This involves submitting a detailed package of all the engineering data, structural analysis, electrical load analysis, weight and balance calculations, and the results of ground and flight tests to the DGCA for review and approval. It's a rigorous process designed to ensure the modified aircraft is perfectly airworthy and safe. But here's a truly game-changing development. Air India has also received design organization approval from the DGCA. This makes Air India the first airline in India to be able to independently make and approve certain design changes in-house. This is a massive competitive advantage, allowing the airline to accelerate future fleet upgrades and respond much more quickly to changing market demands without relying on slower, more expensive third-party firms. Beyond the immediate benefits to the passenger, this project delivers significant operational advantages through something called fleet standardization. By operating a fleet of aircraft with identical cabin configurations, an airline gains a multitude of efficiencies. Crew training is simplified because flight attendants do not need to be trained on multiple layouts. This enhances safety and efficiency. Maintenance is streamlined as the airline reduces the need to stock a wide variety of spare parts for different cabin interiors, lowering costs and speeding up repairs. Standardization also allows for greater flexibility in aircraft scheduling. Airlines can easily swap aircraft on different routes without worrying about differences in seating capacity, allowing them to better match capacity with demand. Finally, for the passenger, a standardized fleet ensures a consistent brand experience. You know what to expect when you book a flight, which builds brand loyalty and trust. It's a true win-win situation. So, has it been a success? The true measure is the verdict of the passengers, and the initial feedback on Air India's retrofitted A320s has been overwhelmingly positive. The airline has been consistently recording a high Net Promoter Score, or NPS, for its narrow-body operations, a clear indicator of rising customer satisfaction. The revitalized A320 fleet now operates on 82 domestic and short-haul international routes, bringing a transformed travel experience to millions. The revitalization of Air India's A320 fleet is more than just an aircraft refurbishment project. It is a powerful symbol of the airline's resurgence. It is a story of ambitious vision, meticulous planning, and brilliant engineering execution. The project has not only enhanced the passenger experience, but has also laid a strong foundation for future operational efficiencies. As the iconic Maharaja continues its journey of transformation, with the retrofitting of its wide-body fleet already underway, the revitalized A320 fleet stands as a shining example of what is possible when a clear vision is backed by world-class engineering and a relentless focus on the customer. It has not just revitalized a fleet, it has reignited the spirit of an airline and set a new benchmark for aviation in India.